Rohayu ada? Telah masuk dalam ni?
Ada. Alhamdulillah.
Mungkin kita bagi sedikit masa lagi sebab sekarang ni masih baru ada 11 peserta. Mungkin kita bagi masa lagi dalam 5 minit. InsyaAllah. Boleh ya?
Boleh.
So puan dari rumah?
Hari ini work from home dari rumah. Alhamdulillah.
Okay. Tadi sementara menunggu tu saya meneliti gambar-gambar yang sebelum ni. Rupanya ada sesi bergambar bersama MIROS pada 2008.
Ada. Memang ada.
The Process Time Series.
Betul. Process Time Series.
Yeah.
That was baru beberapa bulan waktu tu baru beberapa bulan di MIROS lah, because MIROS has been established in 2007. So 2008 waktu tu Prof Radin lah, dia kata we should go and establish contact dengan INSPEM lah, dan minta INSPEM ajar, dia kata macam mana nak buat prediction model. Okay. Dan the course tu actually was the first course even for the ROs lah, because we are still new, and then ramai RO pun waktu tu baru join MIROS as their first job. So ramai engineers jugalah yang join the time series course tu. It is an eye-opening jugalah pada diorang kan, because diorang so far engineering tak belajar sangat lah on prediction model.
Ya. Kebetulan pada masa yang sama Prof Imon ada di Malaysia. Ya. Dan dia sebelum ni dia setiap tahun lah alternate, kadang-kadang datang, tahun depan datang. Tapi disebabkan COVID ni, itulah dia tak dapat datang. Saya cuba juga menghubungi Prof Imon tentang di seminar mingguan, tapi mungkin sekarang tu pada sebab perbezaan masa di US.
Betul.
So dia mungkin dia tak dapat ni. Tapi alhamdulillah lah, seminar ni dapat diikuti. Kita pernah buat dengan di US pernah, so dapat bentang di sini dari Nigeria, dari Peru. So dah tersebar luas lah. Dan para peserta pun juga ada dari Nigeria, Iran, Iraq, dari Thailand.
Wow, very impressive. A very good platform lah, because statistics ni widely used.
Yeah. Dan bila COVID ni, pandemik ni, rupanya kita dapat buka lagi luas kan.
Betul. Kalau tak dulu nak travel, of course there will be cost like kan. Even if you want to present to conference overseas ke apa ke, costing will always be one of the main factor lah, kita nak kena fikirkan. But now with the pandemic ni, as long as you have connection, internet connection, okay je.
Dan semua orang dah boleh accept dengan norma baru ni kan. Nampaknya tersangkut pula pun. Okay. Mungkin lagi dalam 3.20 kita akan mula, insyaAllah. Okay, boleh saya mulakan? Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, dan salam sejahtera. Alhamdulillah, bertemu kita sekali lagi di seminar minggu INSPEM. Dan hari ini sedar tak sedar kita dah sampai ke minggu yang ke-10 untuk siri yang ke-10, seminar minggu INSPEM. Dan pada siri yang lepas, kita telah ada dengan ramai penyidik yang telah membentangkan ini. Dan minggu lepas, kita telah menjemput penyelidik daripada FRIM. Dan hari ini, kita juga menjemput penyelidik daripada industri. Dan insyaAllah, mungkin ini adalah peluang ataupun ruang untuk mungkin ada jalinan kerjasama antara universiti dengan industri. Dan ruang ini juga mungkin adanya peluang lah untuk menjalankan penyelidikan bersama. Dan alhamdulillah hari ini Puan Rohayu Sarani sudi untuk membentang di seminar minggu INSPEM. Dan sebelum kita meneruskan siri seminar ini, saya bacakan sedikit latar belakang mengenai beliau. Puan Rohayu Sarani merupakan pegawai penyelidik di Institut Penyelidikan Keselamatan Jalan Raya Malaysia atau lebih dikenali sebagai MIROS. Beliau mendapat pendidikan ijazah pertama dari Universiti Teknologi Mara dan seterusnya melanjutkan pelajaran peringkat master di Institut Kebahasaan Malaysia. Bidang beliau adalah bidang statistik dan beliau juga aktif dalam penulisan dan telah menghasilkan 2 kertas polisi dan lebih daripada 30 kertas penerbitan ilmiah. Dan tanpa meninggalkan masa, saya jemput Puan Rohayu Sarani untuk menyampaikan pembentangan beliau yang tajuk Some Statistic Application in Road Safety. Dengan segala hormat yang disilakan.
Okay, thank you very much, Dr. Rohayu. Okay, Bismillahirrahmanirrahim. Alhamdulillahirrahmanirrahim. Wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Sorry. Okay. All right. So I'm sharing my screen right now. Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon to all audience, especially our INSPEM friends. And thank you for inviting me to present today on some statistics application in road safety. And for the fellow senior researchers, senior lecturers, and all participants, I hope you will enjoy some knowledge sharing, I would say, because I am not really an expert, but I'm just trying to share what statistics or how statistics has been applied in road safety research in Malaysia. Okay. MIROS, actually a little bit of MIROS. MIROS was established in the year 2007 and by the late Arwah Datuk Radin, who is actually a familiar faces, I think, among UPM students and lecturers, because he used to be UPM's Vice Chancellor in the year, I think, 2010 or 2011. So when he started MIROS in 2007, there's a lot of road safety things that I myself need to learn, because road safety is actually affecting our daily lives. But really, I believe that we receive little attention from the public, especially in terms of how we could be a safer road users on the road, right? So MIROS was established, and we have here some of our PC3 lab. This lab is actually for us to crash a new car and give star ratings to the new car before it is sold to consumers in Malaysia. So our aim is to have a 5-star vehicle, so that if crash happen, the car would be able to somehow reduce the injuries of the occupants inside. Right. We also IRAD Center of Excellence. IRAD is actually one of international road assessment program, of which internationally we try to give ratings to our road so that our road users are safe. So this rating is actually different for each road users. So we hope that our roads are safe enough for our road users. And we also have ASEAN NCAP here. ASEAN NCAP is actually a center for ASEAN where it is a program to create safer vehicles. PC3 is our facilities, and ASEAN NCAP is the organization behind that allow our vehicles to be at least reach at certain safety standard before it is released to public. All right, so I will start a little bit of abstract here. We know that globally, it is about 1.35 million life lost due to road crashes globally. And actually, in Malaysia itself, our fatality rate per 100,000 population is 23.6, and we experience about 6,000 deaths yearly. And this figure is a lot because COVID, the recent COVID is about 6,000 for a year, kan? But we have been promoting mass campaigning on how people should be taking care of their environment. I mean, wash your hands and avoid social distancing or whatsoever. And every day we hear about COVID. But road safety doesn't receive the same attention, even though we have 6,000 deaths yearly. So on average, while we are talking, actually 18 lives was claimed on the road. All right, so I am here today. I would like to highlight some statistical models applied in road safety so that some intervention analysis and also a little bit of time series prediction and our road safety performance. All right, so this is the scenario. This is from World Health Organization. 1.25 million killed every year. 92% are from low and medium income countries, and every 6 seconds are killed. So my presentation, I will mention about road safety scenario first, and then my first project on the prediction model. The second project on non-exclusive motorcycle lane, and the third project on measuring road safety performance. So I hope that this talk is not that technical because I'm trying to avoid jargons or mathematical symbols, but rather trying to give a brief explanation on how things are done and how it is how statistics is applied. All right, so on the global rank, where are we in Malaysia? So we can see that Malaysia is ranked number 126. So we are still far from the best country practices, of which, if you can see, Sweden, Singapore, they are the best country in road safety, because basically all these countries, they have less than 10 deaths per 100,000 population, while us, we have 19.6 in the year 2018, and last year, due to pandemic, COVID-19, we cannot go out, we just stay at home. The number of crashes has been reduced significantly. And last year, our fatality rate per 100,000 population is about 14. So if we want to keep to less than 10, maybe what we should do is just stay at home like last year. But of course, that might be not possible because a lot of economic activities need to be conducted. All right, so this is the current trend. Our world population is about 7.8 billion, and then our road traffic death is about 1.3 million. Our estimated population is about 31 million. And here we could see that the world's average is about 17, and Malaysian average is about, as I said earlier, we are at 23 per 100,000 population, and the world's average is 17. So we are on the on the dangerous country, I would say, on road safety. All right. So per day is about 17 deaths. And here, if we compare ourselves with our ASEAN countries, we are the third highest after Thailand and also Vietnam. And we can see that our Indonesian friend, even though they have a lot of motorcyclists, but their rate is a little bit lower, much lower than us. So there is actually some discrepancy in data, whereas where Malaysia, we collected the whole Malaysian number of deaths, but Indonesia, they have some difficulties on collecting statistics from for the whole Indonesian, because they are very wide. So again, I think the same case for Philippines. They are not actually countries. It is not per countries numbers as a whole, but based on certain area, and they have a lot of underreporting. Underreporting means there are certain times that when crashes happen or when death happen, people didn't go to police to report. So Malaysia, it is compulsory for you, especially if it is involve fatality. Then we need to report to the police before we can make any insurance claim. So similarly, for other countries also, but there are certain countries that has some limitation in collecting the data. Okay, so this is root user death in Malaysia in absolute number. So where are we? We are, as I said just now, we are at 6,000 a year. Never been less than that since 1995. So the orange line here is the actual fatalities. This line here is the predictive fatalities. So in the year 2030, we forecasted that the number of deaths is about 5,300. However, WHO they established Sustainable Development Goals, SDG. I believe if you are aware of all these targets set by WHO, they have, I think, 17 areas where they want to improve human lives. So there are actually 17 areas, transport, health, and also road safety, education. They want to improve the world for better. So they create these sustainable development goals. So one of the goals is for road safety, which we, WHO has targeted that we need to reduce 50% from the year 2020 actually. But because 2020, we have this special structural change, I would say, for COVID-19. So we use the figure for the year 2019 as baseline for us to predict. So by category, we could see that in Malaysia, the biggest chunks of number of deaths are our motorcyclists. So they are the most vulnerable road user. I would say motorcycle 66%, pedestrian 6%, car 18%. So if you are trying to be on the safer road user, please, please change your mode of transport if possible. But if you can't help, please be a good road user, because motorcyclists, they are the most vulnerable here. All right, now I will talk about the data. Okay, the data that we have in MIROS, a few data that we collect ourselves, which we call as primary data, and we also have secondary data. So among our primary data, actually MIROS crash investigation, and also IRAP. This is International Road Assessment Program, and also we have road safety inspection. RSI data. RSI data means that whenever a crash happens, usually our road engineers will go down to that crash location, and we will try to figure out what is wrong with that particular route, what can be improved so that crashes won't happen again. And our MIROS crash investigation, usually we investigate crashes that has a high number of fatalities, usually three fatalities or more. Or if it is a crash involving VVIP or involves heavy vehicle. So if you still remember, last time there are cases of accidents involving our MP near Simpang Pulai, and also there's also one here in Cheras or Balakong, I'm not sure. But there are certain, I believe since MIROS establishment, we have investigated several VVIPs crash, and we're trying to come up with what are the reasons behind the crash. For our secondary data here, we have our poll 27 from Royal Malaysian Police, and we also have reports from Global Status Report on Road Safety from WHO, and we also subscribe to International Road Traffic and Accident Database, IRTAD, and at the same time, we also use data from various government agencies, especially Department of Statistics Malaysia, and also Road Transport Department for licensing, for vehicles information, and also for regulation, road safety rules. They are all under road Traffic Department, RTD, Jabatan Pengangkutan Jalan, and also Ministry of Work. So for Ministry of Works, a lot of road information that we collect, basically for state road and also for federal roads. All right. This is the main data source that we usually use in MIROS. This is poll 27. It is actually a form that is used by our police to collect all the information of the crashes whenever crash happen. So we have part A, which will give us report details and incident, time, date, and also the day of the accident, how many drivers killed, how many pedestrians killed, how many our passengers killed, and what type of crashes it is it fatal or just damages or slight injury. And part B, we have some road attributes, whether it is a one-way or two-way road. Is it in the junction, or is it along federal highway, federal roads, or is it what are the characteristics on the road itself? And part C, we have some environment on the weather during the crashes. Does it happen during rainy season, or does it happen during dry? And we have also information on the location to the nearest kilometer post. We also have some vehicle details, what type of vehicles the user are riding or using. And if it is bus, what kind of bus, motorcycle, how many cc, and what are the possible, who are the owner, and on the driver details, we have all the details of whether male, female, Malay, Chinese, Indian, or what are the injuries that they sustain, whether or not they use helmets, whether or not they use seat belt, and do they have license, and so on. Right. And we also have here, behind here is the diagram, how the crashes happen. All right. Next data set is IRAP. IRAP Malaysia. This is where we collect our road environment characteristics. So we use video cameras connected to GPS. We drive through all our roads. So basically, we have covered federals and also some highway. And we review images for every 100 meter so that we could tell if there is a change in number of lanes, for example, the width of the road shoulder, is it a junction or is it a roundabout, and so on. And we give star rating to our roads. So the reason why we collect IRAP, we use IRAP Malaysia, is actually we are trying to find what are the suitable countermeasures to improve our roads. All right. I'm going to explain my first model here. The first exercise that, not really exercise, the part of my research in MIROS, which I use time series model to predict the number of road death. Okay, why do we need this time series prediction? Okay, under Malaysia Road Safety Plan, we already have the first plan in 2006 to 2010. And also we have second plan, Road Safety Plan in 2014 to year 2020. So for each plan, we need to come up with a prediction model on what are the number of fatalities that we might have during that plan period. So for example, for 2006 to 2010, we plan that we use ARIMA model last time. Where we use number of vehicles, and we predict that we plan, I think the number of target is actually 10 per 100,000 population, 10 death per billion VKT, and also 2 deaths per 10,000 vehicles, something like that. So we have all these targets, and we will spell out how we can achieve the target inside this plan. So that is Road Safety Plan 2006 and 2010. The second plan that I'm involved was Plan Keselamatan Jalan Raya 2014 and 2020. Now the third plan, 2030 is on its way. So for the second road safety plan, I use ARIMA model to predict the number of fatalities for the year 2020. So as you can see here, we have the series from 1972 up to year 2020. So the data that we use to predict is up to year, if I'm not mistaken, we used up to 2010 for model development, and 2010 to 2013 for model comparison, for us to check whether our model is good or not, how good it is. So the best ARIMA that we use for this fatality model is ARIMA 011. So this prediction model has been used, and we produce this in the Journal of Australasian College of Road Safety. So the reason why we use univariate model for ARIMA is because it is quite difficult for us to incorporate other intervention. For example, if we have road safety education, what will happen and so on, simply because we don't have that long series for that particular variables. So we opt for univariate. So based on the model, we can see that we predict that for the year 2020, we will have 10,716 number of deaths. It is quite, I think, scary to if the prediction becomes reality. But luckily, under road safety plan, from the target itself, we target from the predictive model. We plan for 50% reduction on road fatalities. So our prediction says that 2020 we are going to have 10,716. Then we set our target to be 5,358 in the year 2020. So we work with all other parties, JPJ. We work with Ministry of Works. We work with our road safety education, and we try to install our EES within that period so that we could have that reduction of 50%. So in the year 2020, we have 4,634 number of deaths. But we cannot claim that this 4,600 is purely due to road safety intervention, of course, because part of it is contributed due to COVID-19 pandemic, where we stay at home. So these things, there are things that we can't predict actually. So comes 2020, now 2021, again, we need to repeat the same exercise for our third road safety plan, so that we need to plan for 2030. So again, I use ARIMA here for model development. I use data from 1981 to 2015. And for validation, I use data from year 2016 to 2019. So as you can see here, the green line are the new prediction model, and the yellow are the actual fatalities. Again, we hope that we will be able to reduce 50% from the year 2019. But it seems like even though it is possible, but it needs a lot of hard work, I think, to be able to reduce 50% from 6167. It means that by 2030, we targeted that our road safety should be around 3,000. And to do that, of course, we need to introduce more intervention. So based on this prediction model, there are a few assumptions that we put in, that we hope that the current road safety initiative, such as automated awareness safety system or speed camera here, road safety education for continue to be in place, so that all our road users are well educated on road safety. We also assume that our NCAP and IRAP are all in place, and other initiatives that currently in place will be continued as normal. And we hope also for the 2021 to 2030 period, there are no other new policies that will increase the number of personal car into the system, because the more vehicles we have on the road, the more riskier it is for our road users. Hence, we hope that people will start moving from personal vehicles to public transport. But it seems like an ambitious target. So this is the model from the ARIMA. As you can see that the confidence interval, the upper and lower confidence intervals are quite wide here. It means that this model here, ARIMA, might not be a good model because the error rate seems to be high. So the questions that need to be answered from this research: how good is the prediction? How could it be better? In road safety, other than ARIMA or Poisson or negative binomial model, there are also experts who use state space model. State space is also falls under time series family, but it is more robust, I think, in terms of defining the level and also interdependencies between observation. And another things that we need to think of, since we have our pandemic COVID-19 in the year 2020, there will be a structural change. So maybe actually the prediction need to be revised in the year 2030, 2023 or 2024, so that we could incorporate the effect of that COVID. So that sum up on my prediction model. It is sometimes it is not an easy task, because when you are dealing with data, real data, I mean, and you need to be able to try to see whether the data, how you could do best with your data, because whatever data that you found in your textbook is already sometimes already apa kita nak kata it is good, but it has been altered sometimes to suit the analysis inside the textbook. But when it comes to real data, and when you have to explain to your stakeholder, for example, to your minister on the prediction and whatnot, you can't help to have a model that is too complex, because the complex, it is the harder for them to appreciate the work. All right, now I'm going to the second research that I am involved on predictive modeling. So this predictive modeling is actually, we're trying to classify a certain observation, whether it falls under category A or category B. So in this study, I use logistic regression. For MIROS, I have used logistic regression for the following research. One is the most recent one, analyzing the effect of non-exclusive motorcycle lane, NEMCL. If you are a motorcyclist rider, you will be able to appreciate this, especially if your road along your journey, if you have this non-exclusive motorcycle lane, you will be able to appreciate. And the second project that I used to work on logistic regression are effect of driving and working hours for bus driver. This was back in 2008, where we tried to establish what is the most, the maximum driving hours and working hours for bus drivers. And the third project, effect of MSD, musculoskeletal disease, among motorcyclists. MSD is actually, this is widely used in ergonomics, where we try to reduce pain, back pain among motorcyclists. So this is non-exclusive motorcycle lane. If you have, if you observe in our roads here in Malaysia, we have this painted red and also a little small lane here. This is for motorcyclists, and this are for car and other vehicles. And here, the map here shows a list of motorcycle lanes. We have all these pink legend are actually non-exclusive motorcycle lane. The purple are the exclusive motorcycle lane. Exclusive motorcycle lane means that the lane is specifically designed for motorcyclists. So this is the intervention for motorcycles that we have currently in Malaysia. One is exclusive motorcycle lane, where we have about 5.5% out of total length of our Malaysian road. We have this exclusive, and it is actually proven that this exclusive motorcycle lane reduce number of accidents up to between 25% to 34%. We also have the non-exclusive motorcycle lane here along federal roads. You can see this in Kedah, Johor, Perak, and some parts of, I think, Kelantan and Terengganu. So it's about less than 1% of our road are equipped with this non-exclusive motorcycle lane. So in one of the research, it says that this non-exclusive motorcycle lane may reduce crash risk by 80% as compared to the section without. So the challenges here is the coverage for this motorcyclists are still very low. And we also have problems of other road users going into this lane and disturb the traffic flow for motorcyclists. So this is actually misuse of lane. So we also have guidelines that still to be tested and adopted. So in order to come up with this project, what we do is we combine 3 data sets. The first one is the crash data, which from the PDRM, from Police Pool 27 just now that you saw. We also have some IRAP data. This IRAP data is will tell us whether that section, road section, whether they have these facilities or not. And we combine with ArcGIS data. ArcGIS means we use the coordinates for both IRAP data and the crash data that we have, and we combine them so that we know for that particular coordinate what are the crash number, what are the crashes that happen, and whether or not that crash happened on motorcycle, on non-exclusive motorcycle lane or not. So each data point here represent 100-meter road section. All right. So what do we use to predict this? Okay, our model is actually for us to model the accident type here, whether or not the accident is fatal or non-fatal. The difference between fatal and non-fatal, fatal at least involve death, at least one death. Non-fatal means it just warded or slight injuries, also slight injuries. So here we use descriptive statistics. We also use cross tabulation, and we run our logistic regression model. So we could see here from our cross tabulation, we see where along the area where no facilities for motorcyclists provided, we have 38% of fatal crashes. Whereas for stretch of road that we provide non-exclusive motorcycle lane, the number of fatal crashes are slightly lower, 30.2%. So on this logistic regression model, there are several variables that we include to be able to predict whether or not that crashes happen is fatal or not. So the variables that we put in is, of course, the main important thing is whether the facilities of motorcycle lane is provided or not. So that comes under facilities, and we have traffic system, whether it is a one-way, two-way, three lanes, or dual carriageway, because this number of carriageway will actually impose speed. The more lanes you have, you tend to have a higher speed because you are free to speed. Then we have route geometry, whether it is a straight road or bend or cross junction or interchanges, and collision type. This collision type could be overturn, head-on, or rear, or right angle side. And these are the terms that usually you need to understand clearly if you are doing road safety research, because this type of accident definitely there are causes why this certain collision type happen at certain type of road. Okay, so our aim is we are trying to establish what are the factors that contribute to fatal crashes for stretch that have exclusive motorcycle lane and also for non-exclusive motorcycle lane. So we have a long table of results here. I'm not going to read one by one, but I believe that if you are familiar with regression and you are familiar, especially logistic regression, you will be able to understand the coefficient, what the coefficient are trying to tell us, and also what we are interested in is actually more on the exponential beta. So the exponential beta for facilities for motorized two-wheelers here, as you can see that one is where the baseline where no facilities are provided. So it is means that our baseline is normal roads, no facilities. So based on our model, we could see that here, on the normal roads, the probability of getting into fatal crashes are higher by 1.5 times. So these are the results that we get from our data. Again, for other variables, of course, if you are driving on the straight road, the risk is higher as compared to when you are at junction or interchanges, because straight road people tends to drive faster. So the baseline for road geometry is the lowest risk, which is Stepwise, target junction, and interchanges. So all other types, all other areas, straight road, bend or crash or cross junction, are riskier than at the junction. It is usually straight road tends to be more higher, pose more higher risk as compared to others. All right, for collision type, the baseline is overturn and head-on, rear angle, angular swipe, side swipe. These are all have more risky than overturn. All right, for traffic system also, dual carriageway is the baseline. So we can see that one-way, two-way, three lane are less riskier than the dual carriageway. What else? Okay, these are the findings. Fatal crashes are significantly higher at normal roads. where non-exclusive facilities are not provided. There's also significant difference in the outcome of accident severity depending on different type of roads, geometry, and collision type. Road geometry, facilities provided, and collision type and traffic system are significant predictors for fatal crashes. This one I had mentioned earlier. Odds ratio of 1.5 indicates that crashes that occurred at normal roads are more likely to be fatal as compared to roads with non-exclusive motorcycle lane section. Okay. A little bit of caution on the results. This study is actually based on all types of crashes. So there is a possibility a different results will be obtained if we set our condition that the crashes should be involve motorcycles only, and that might give a different results. So a data point here is for every 100-meter road section. So a better analysis could be a segmented road section analysis, and small or ratio 1.5 on the protective effect of non-exclusive motorcycle lane is not really a significant result that we hope for. So there are many things that we could improve on, most probably on the design of the non-exclusive motorcycle lane, so that other vehicles won't be able to penetrate or violate the lanes. And other types of model could be explored. Again, because statistics model a variety, and we have a lot, and that only on logistic regression. Okay, I have come to the third research that I plan to share with you, which is stepwise or joint point regression here. Okay, we know that from the fatalities and ARIMA models that we developed, we saw that the number of deaths are increasing every year. Somehow, if we use other than ARIMA, we would observe that there is like a turning point, a change of direction in the year 1996. The slope of the line is getting, what we say, it is not actually monotonous, but it's getting kecil sikit, kan? So this turning point in the year 1996 has been highlighted under Prof. Radin's one of his paper in 2007, but it has not been tested. So what I did, this is also a recent project. I tried to plot personal risk and also motorization rate here. Are we okay? Right. So the blue line here is personal risk. Personal risk is defined as number of deaths per 100,000 population, because this is actually the objective of the project is we want to see whether or not our road safety has improved since 1972. We have done a lot of interventions, so there must be some improvement, but we want to have proof. So that's why we conduct this research. And we plot against, we plot this personal risk against motorization. Motorization rate here is number of vehicles per 1,000 population. So if, as we can see in the graph here, if we assume that there's only one turning point here, which is highly visible here, then we can see that there's a trend going up before 1996. And there's also one trend here going down post 1996. So this research that I conducted is trying to model whether or not this personal risk has reduced. So this is the result that I got from the piecewise regression. So piecewise regression is basically we're trying to model this part before the turning point in the year 1996 and also after the turning point. So we could see that if we plot against motorization rate, we know that our number of fatalities, our personal risk keep on increasing up to 363 vehicles per 1,000 population. So for every 3%, we have one car. So up to that point, our number of death or personal risk keep on increasing. Then we have a turning point here. After that, we have a negative slope here. So what we could deduce from the graph is from the early 70s to mid 90s, the positive coefficient of motorization rate indicate that every 1 unit increase in motorization rate, the personal risk is expected to increase by 0.026. When the motorization lapse 363, the coefficient is negative, where personal risk is expected to decrease by 0.01. So Malaysia road fatalities started to stabilize when the personal risk reached 29.7 death per 100,000 population and motorization rate at 363 per 1,000 population. So if we consider this, if the analysis is correct, we could say that our personal risk has reduced since 1996. Again, of course, each research we will have limitations. So the limitation that we have for these projects are the number of vehicles used are based on cumulative figure. It means that the vehicles keep on adding up from the year 1980s. So it could be that we dispose our vehicles usually after sometimes, right? The most that people use their vehicles most probably 10, 15 or 20 years. So if we use this cumulated number of registered vehicles, it means that we never dispose our vehicles. So that is one of the limitations. So another limitation is there could be more than one turning point. As I mentioned earlier, the research in MIROS where you need to explain to your stakeholder, usually we try to avoid complex, but we try to be more useful rather than complex, because the equation, the harder for our stakeholders to understand. So better analysis could be conducted if we use the number of active vehicles and also if we opt for a model that is sensitive enough to detect for changes in trend. So we could see that there are several turning points actually. All right, so that sum up more or less on what are the research that I have involved in MIROS. So after this, I'm going to explain a little bit on MIROS research cluster, which actually we open up for researchers, outside researchers to join us, because MIROS actually has more than whatever that I explained earlier, because our research center is actually divided into 3 centers. One is for the vehicles, one is for human behavior, and also the other one is for root engineering. So our centers are actually 3 centers. And based on these 3 centers, we form a research cluster. As you can see here, we have advanced passenger safety protection, driver competency, fitness to drive, and whatnot. So all these clusters actually, we work together. We welcome participation from outsiders. If you could contribute to our clusters. So my cluster is road safety progress and performance monitoring cluster. So basically we are trying to, as I mentioned earlier, for our road safety plan 2021-2030, we want to reduce the number of fatalities by 50%. So the target is quite ambitious, but we believe that we have to do it, else we will be sad because there will be many people die on the road, right? We don't know whoever that die, it could be our little brother, little sisters. So we must work together to reduce the number of fatalities here. So whether or not that is achievable, we need to do some research on that, achievable or not. Because based on our road safety performance just now, we know that with the current population and also motorization rate, our system that is in place now is only able to absorb about 1% of our fatality. So more than that, we will have more fatalities on the road. So what are the things that to be addressed under this cluster? We have road safety progress, which we will look into adherence to road safety regulation, where we are going to monitor seat belt, front and rear, and child restraint, drugs and alcohol, helmet, mobile phone, and also speeding among our road users. The second is on the monitoring part. We need to monitor programs, our road users, our yearly indices, and also state and country performance. And what are the areas that can be improved through better data? And of course, the forecasting and socio-economic impact. So these are the things that we need to monitor: death per 100,000 population, by age group, by gender. We need to know more which age group has shown a decline or an increase in traffic death, so that we could tailor our intervention for better results. And death per 10,000 vehicles, we are trying to come up with an index for motorcyclists and also for passengers. And by geographic site, we also try to come up with an index for state, locality, and also for vicinity, so that we try to get public to understand road safety, so that they could be a better road users. Okay, now the time is 4:18. Before we go for questions and answer, I would like to share one video, fatigue video. Basically, this video we used to share among our participants during road safety talk. So basically, researchers at MIROS, we need to give road safety talk also to government agencies, other than some kind of these technical talks. All right, let me share. And enjoy the video.
Don't talk to me, hon.
No.
Yeah, come on.
No. Pull over if you're tired.
Okay. All right, so we are open up for Q&A. Okay, that comes to the end of my presentation. So open up for Q&A. And if you have time, please look into our website, miros.gov.my, and you will be able to appreciate more of the research that we conducted in order to prevent crashes and injuries on the road. Thank you.
Okay, terima kasih Puan di atas perkongsian yang sangat menarik ini. Dan kita buka untuk soal jawab sekiranya ada soalan ataupun cadangan ataupun komen. If you have any question, you can raise here.
Dr. Raizat?
Yeah.
Okay, Puan Rohayu.
Yes.
So thank you very much for the presentations. So I'm Lee from INSPEM. So I have just one question. Since by looking at your presentations, the model that you're presenting, time series and regressions, right? So this is, if we classify it under the analytic part, it will be descriptive and diagnostics.
Yes.
So have you actually done any predictive and prescriptive analytics, or by using the data that you have in MIROS? Because yeah, I mean the regression is just some straightforward statistics. So have you actually used any I think AI techniques like the machine learning to get a better predictions, or maybe a more accurate results?
Okay.
Thank you.
Thank you for the questions.
Okay.
Basically, the predictive model on the time series model that I use, I would say that we don't really employ machine learning yet in MIROS. What I did is just I run that ARIMA model using SPSS additional package, time series model package. So from the package, they select the best model that describe the data. And I also run the same analysis using R, also under ARIMA, and it gives about a similar result. So I haven't tried machine learning yet. I believe that we could try. There's no harm in trying, because actually we don't really have the facilities for machine learning.
Okay.
All right, thank you very much.
Ada soalan lain? Any questions? Mungkin
any more questions?
Mungkin ada yang akan berhubung dengan Puan selepas ini mungkin, insyaAllah.
Yes.
Jika tak ada soalan, sekali lagi saya ucapkan terima kasih kepada Puan Rohayu di atas perkongsian dan seminar yang diberikan. Mungkin selepas ini mungkin ada susulan ataupun perancangan lain yang kita akan jalankan selepas ini, insyaAllah. Dan saya juga ucapkan terima kasih kepada para peserta yang ikut serta pada pembentangan ini. InsyaAllah jika ada masa dan acara yang akan datang, kita akan jumpa lagi, insyaAllah. Terima kasih saya ucapkan. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you everyone.